All right, so we are going to do R2 now. Right there is good. Thank you. Oh, put my mic on. Now you can hear me better. All right, let's do this. So everybody ready to take notes? You shouldn't just be sitting there and watching with your head down, right, Kyle? Okay. I want to see your eyes. That's all right. It's no big deal. What do we call this thing right here? It's a line. Okay, it will be a number line. Okay, so let's put some numbers in here. And let me, tell you what, before I change colors, -3, -2, 1, 0, 1, 2, 3, 4. Now it's a number line, right? Because we got some numbers on there. So what we're going to do now is we're going to put a dot at one of these numbers right there. All right, so it's a pretty simple question. Where is that number located? Or was that dot, where that point, I should say, located? It's at 2, all right? So we call this a coordinate. That's a word that you're going to see a lot in math. We'll talk about that a lot. So this is the first time we've talked about it, at least in here. We call this a coordinate, all right? So if I put a point, and sometimes I'll do this. I'll put a letter with that point. I'll say, what is the coordinate of point A? And you would tell the number that it's associated with. Okay, you would say it's 2. What's the coordinate of A? What if I put a B right here and I put a dot? What is the coordinate of point B? It's -3. Pretty simple stuff. Do you agree? Yeah. But we have to know that before we know the other stuff. So that was pretty simple. Everybody got that written down? I'm going to pop it up here. Okay. All right, let's do another one. Let's go back to white with the number line. Again, a lot of this beginning stuff is super basic, but it's good to have a foundation. And let's do this. Let's do this. We'll change colors again here. Oops, I thought I changed colors. Let's try it again. There we go. All right, so I put a point here and a point here. We're going to call this A and B. This just seems too easy, but I'm going to ask anyway. Which ones? You don't know what numbers they are, do you? Okay, it stands for a number. It doesn't really stand for the point. It stands for the coordinate of the point. Okay, which is the bigger number, A or B? B. Why is B bigger than A in this situation? Because it's to the right. Very good. It's to the right of A. If it's to the right, then it's bigger. So A is what to B then? A is less than. Because why? A is left of B. Right. It's to the left of letter B. Everybody with me on that? Again, I told you it's pretty basic. What if I put, I'll just keep this in red. What if I put, let's do this. I'm not going to do that part. Forget that. That's kind of silly. Let's just do this. Let's get rid of that. And let's get rid of that. Now, does the fact that B is bigger than A have anything to do with B comes later in the alphabet or anything like that? So if I put a B here and an A here, which one's bigger now? The A is bigger now, okay? It has nothing to do with the order in the alphabet that it shows up, okay? It just depends on where on the number line. So if I go to the right, somebody said it earlier, somebody tell me, you are getting bigger, but what kind of numbers go to the right? Okay, I should do this. Let's put a 0 there, okay? To the right of 0 would be what? A positive number. If I go to the left of 0, that would be a negative number. You with me on that? Okay, again, I told you it's pretty easy. Oh, let me do this. Oh, I switched them around. So on this situation, we say that A is what to B? A is greater than B. Do you remember this stuff? Some teachers teach it like the alligator eats the bigger number or something like that. I don't know. To me, it's this. Do you know where they get this less than, greater than thing? Because what does that symbol mean right there? It means equal to, right? So what happens if I take that top one, tilt it, and so now look at the distance between here. It's smaller, isn't it? Okay, look at the distance between here. It's what? It's bigger, okay? So whatever's over here, okay, let's use a different letter, x and y. So how would I read this? X is what? Less than y. Or you could read it backwards. Let's read it backwards from right to left. If I read it backwards, y is what? Greater than x. Do you see that? Okay, because this is a bigger opening. This is a smaller opening. All right, you could do the whole alligator thing if you wanted to. Did teachers ever do that? Yeah, they never did that for me, but my students always say, well, my teacher always said the alligator eats the bigger number. All right, that's cool for little kids, but this is where the less than or greater than thing comes from, okay? You with me on that? That's pretty simple. All right, this is an embarrassingly easy example. It's in the book. Oops. Sometimes I push a button on here, it does that. Let's do, here's a couple examples. I'll just stay in red. All right, this is silly. All right, is this a true statement or not? True or false? 3 is less than 7. Yes, it's true, okay? But you got to know what that symbol means. That's what we're trying to learn here. What about this? Now, when you start getting into negatives, sometimes students get a little confused when you get into negatives. But what about this? And I'm going to leave it blank right now. Okay, what symbol would we put in here? Would we put less than? Would we put equal? Would we put greater than? It would put greater than. That's right. -8 is greater than -16. Everybody with me on that? I don't have to show you a number line with that, do I? Okay. Yeah, that's good enough. Let's just write this. So if I say a is greater than 0, tell me something about the number a. Remember, the number represents, it could represent any kind of number, but tell me what kind of number a is. It's positive. That's right. If it's bigger than 0, it's got to be positive. So if a is what? Less than 0, then it's what? Negative. Good. You with me on that? It's not always going to be this easy. Okay, don't worry. All right. Oh, your favorite. What do you think we're going to do with this less than or greater than stuff? Well, we're not going to do fractions. That's your first favorite. This is your second favorite. Is graphing. I can hear the terror in your voice when I say graphing. It's not that bad. Let's do an example. Let's graph all the numbers. Let's do this one first. X is greater than 4. All right? So here we go. Let's put a few points in here. You need to have 4 in here somewhere, right? But if it's greater than 4, I like to have kind of 4 somewhere around in here. Give me a few numbers that are bigger than it, okay, if I'm going to graph x is greater than 4, all right? So what we do is this. We say it's greater than 4. Do we say x is equal to 4 in this situation? No. So I can't put a dot right on 4. What do I have to put on the 4? I can get super, super close to 4, but I can't be right on 4. Nana, say it. You said it? Open circle. It's open. It means it's really, really close to 4, but it's not on 4. You got it? That's why it's open. It's not really on it. But then I can just kind of darken it in like this. And then put an arrow like that. That's how we would graph it. That's pretty simple, isn't it? Yeah. Let's do another one like this. Let me go back to whites. Oops, what did I do? I did something dumb. There we go. Okay, there we go. All right, let's go back and let's draw another number line. So far, so good. These number lines haven't been too bad so far. Then we'll let's do this. Let's graph this. Let's graph x is less than, what's that little thing I did right there? Or equal to. So now, if it's x is less than or equal to, am I going to put an open No, because it could equal 5, couldn't it? So I want to show all the points. Oops, I should have changed colors. That's okay. And then, whoops, you just kind of make it thick like this. It's kind of ugly, but you get the idea, right? You darken it in, going this way. It's less than, so it goes to the left. It's or equal to, so we put a dot. We good? All right, I got 5 minutes. I got one more thing to go over. So graphing's not so bad so far, is it? So far. No, that was pretty easy. Let's do another graph. Let's talk about something real quick here. Do another graph. And let's go 4, 3, 2, 0, 2, 3, 4. So I'm going to go from -4 to 4, okay? -3, -2, -1, 0, 1, 2, 3. What I want to do is this now. Let's put a dot right there, and let's put a dot right there. What I'm going to ask you is, what is the distance, the length, from one point to the other, from -4 to +3? You could sit there and just do what, since you got the graph right in front of you? You could just count, couldn't you? So let's do that. Let's count. 1, 2, 3, 4, 5, 6, what? 7. 7 places, right? But there's a better way. What if I had this at -5,230 and this at +4,700,000? I don't know, whatever. You know what I mean, right? You wouldn't sit there and count all those, right? There's got to be a better way. So what is the better way to figure out how far is it from one point to the other? What do you think? Did you say add? What did you say? You said something different.
I was going to say subtract.
Okay, that's what you want to say. All right, so watch what we're going to do. We're going to subtract. For instance, if I wanted to find out how to get from 1 to 4, how do you get from 1 to 4? You subtract, right? 4 minus 1 is 3. There's 3 places. Got it? It's the same thing even with negative numbers. And the interesting thing is, it doesn't matter what order you subtract if you do this certain thing. So I'm going to go the distance. I'll put D equals. The distance, or the length, is 3 minus what? Is it 3 minus 4? It's minus -4. Okay? And so what do you get? You get what? A 7. So how far is it? It's 7. We counted. Would you agree? So yeah, it's definitely 7. But remember what I just said. You could count the other way, right? Or you could subtract the other way. So you could do -4, what? Minus 3 from one point to the other. But look, something happens here. I'm going to add the opposite, right? We've talked about that, I think, the other day. So what do you get there? You get a -7. So one's -7, one's +7. But I want the length of something. Do you ever measure something and say, oh, that looks like negative whatever? No, it doesn't matter what order you measure it in, right? You always get a positive number. And we're going to introduce this thing right here. Put this bar and this bar. What does that mean? Say it. That's absolute value, all right? So when you're finding the distance, it does not matter what order you subtract them in as long as you do what? Stick them in an absolute value, because distance will always come out to be positive. You got it? If I ask you for the length of something or the distance, it's always going to come out positive. How can you always make something positive? You can put it in absolute value symbols. What's the absolute value of 7? It's just 7. What's the absolute value of -7? It's still 7, okay? Absolute value always comes out positive. So you do what's inside here first, okay? And then your answer will always be positive, all right? So quick example and we'll be finished. We're running out a little bit of a time frame here, so we'll just do this. What is the distance between -5 and -7? We pretty much just did this. So what is the distance between these two? What would you do? What would your work be? You go -7 minus what? -5. And then you add the opposite. That's -2. But remember, to find the distance, we always put it in absolute value. What's the distance between them? It's 2. All right? That's all there is to it. Here's your homework. Your homework is section R2. let's put an A next to it, all right, because we'll do a couple sections in R2, and we're going to do page 27 and numbers 39 to 83 odds. It sounds like a lot, but you're only doing the odds, and these, for the most part, are pretty short and easy. So that's your homework right there. Everybody got it? If I went too fast, go back, watch it on YouTube. It'll be up tonight. Okay, have a good one.